In this video, we look at the empirical rule. The empirical rule is a way to look at data and utilize the mean and standard deviation to determine what percent of data values are within a certain range of the mean. This is similar to the Chebyshev rule that we had earlier in statistics. So the empirical rule says this, that if we have a normally distributed or a bell-shaped curve that is symmetrical, then we know that 68% of the data will be within one standard deviation of the mean. 95% of the data will be within 2 standard deviations of the mean, and 99.7% within 3 standard deviations. So if we know the mean, and we know the standard deviation, we can determine how much of the data is within a certain number of standard deviations. So if we look at this in a graph, here's a normally distributed bell-shaped curve. Notice plus or minus 1 standard deviation is the middle 68%. Plus or minus 2 standard deviations, if you add up all those numbers, 47.5% on each side of the mean, 95% within 2 standard deviations of the mean, and then finally 99.7%, or practically all of the data within 3 standard deviations. In other words, it's very, very unusual to have a data value outside of 3 standard deviations from the mean if we're talking about a symmetrical, normally distributed distribution. So let's look at an example. Suppose we look at ACT scores. They're roughly normally distributed, so they're symmetrical, bell-shaped. The mean is 21 and the standard deviation is 4. So I want to think about numbers in terms of how many standard deviations they are away from the mean. So if I asked, what percentage of students score between 13 and 29 on the ACT? Well, if I draw my graph, I know the mean is at the center in a normally distributed data set, so here's my 21. And if I have standard deviation of 4, 1 standard deviation above the mean would be 25. 2 standard deviations would be 29. Going the other way, 1 standard deviation below would be 17. 2 standard deviations below would be 13. Notice I start at the mean, and I'm going 4 units above, 1 standard deviation, 2 standard deviations, etc. So according to the empirical rule, I know that within 1 standard deviation we have 68%, so 34% on each side. Within 2 standard deviations, I have 47.5% on each side, or 95% in the middle. So 13 to 29 is the mean plus or minus 2 standard deviations. So according to the empirical rule, that would be 95% of all students score between 13 and 29 on the ACT. Now suppose I asked what percent of students score below 25. So again, if I look at 25, it's here at 1 standard deviation above the mean. Well, according to the empirical rule, 1 standard deviation above the mean, there's 34% there, or 68% between plus and minus 1 standard deviation. We have a symmetrical distribution here. So if I think about this, that means there's got to be 84% below and 16% above. Because remember, the red center line there, the mean, is the 50-50 line. In a normal distribution, 50% of the data is below the mean, 50% above. And the empirical rule says I have 34% up to 1 standard deviation there. So I've got 84% below the value of 25 here. So above that would be 16%, total of 100%. So 84% of students score below the 25 on the ACT. Or another way to think of it, a 25 on the ACT is approximately the 84th percentile.